functions. We looked at piecewise functions, which was one of the types of special functions. We've looked at step functions, which is the second type of special function. So the last type that we're going to do today is absolute value functions, which can be thought of as a piecewise function. So that's why they're kind of all grouped together. So we all know what absolute value really means. The distance that a number is away from 0, right? We've done absolute value equations before. Now what we're going to be, we did absolute value inequalities. Remember less than, our ands, great tors, or. So now we're going to look at what absolute value graphs look like. So if we think of an absolute value function as being f of x equals the absolute value of x, and if we define it as a piecewise function, just one way to think about it, these would be your pieces. Well, if your domain was positive numbers, and you take the absolute value of a positive number, what do you get as a result? The same number, right? If I took the absolute value of 0, I get 0. If I take the absolute value of 1, I get 1, and so forth. So for all the numbers greater than or equal to 0, when I take the absolute value of that number, I get that number. I get x. But what happens when you're dealing with negative x terms, when your domain is negative numbers? Well, when you take the absolute value of a negative number, it really, now wrap your brain around it, it really turns out to be the negative of that number. For example, if x was negative 2, what's the absolute value of negative 2? Positive 2. What's the negative of negative 2? Positive 2, right? So if you're taking the absolute value of negative numbers, really you're taking the negative of that negative number, and it becomes a positive. What's the negative of negative 2? 2. What's the absolute value of negative 2?
So it's almost
2.
like if the...
It's the same thing.
How do you remember to do
It's almost like you get rid of the negative and you...
put it back?
So the negative of a negative becomes a positive, right? All right, well, let's see it in action. Here we go. Here's our first one. We're going to just graph the basic f of x is equal to the absolute value of x. I'll give you a second to get yourself set up. Now, if we were in Algebra 1, we'd kick it back old school, make a table of values, and then graph it. Okay? But what's tricky about absolute value functions is sometimes if you just pick negative 2, negative 1, 0, 1, and 2, those aren't good enough to see the shape of the graph. Okay, so table of values, yeah, they work, but sometimes it's better to think about it as a piecewise function. Okay, so if I were to rewrite this as the piecewise function, it would be f of x is equal to my fancy bracket. I'm going to do the negative version first. So for all numbers less than 0, when I take the absolute value of a negative number, it turns out to be what type of number? Positive. So if I needed to write that out, because I can't write it in words, I need to write it out mathematically. If I take the absolute value of a negative number, it's going to end up being the negative of that number. What's the absolute value of negative 3? 3. What's negative times a negative 3? 3. So it gets me the same result.
I'm so confused on why it has to be negative.
Yeah.
Because if it was positive, okay, someone give me a negative number.
-2.
If I substitute negative 2 in here, what do I get? Negative 2.
I see.
Is that true? As an input of negative 2, do I get negative 2? No. It's going to be positive 2, so it needs to be a negative of it. So for your negative numbers when dealing with absolute values, it's the negative of it to make it become positive. All right, so then for our positive numbers, including 0, it's just going to be x. So now let's think about graphing our piecewise functions. Where am I going to start? 0. What ordered pair do I get when I plug in 0? 0. Is that going to be an open or a closed dot? Open for now. So I'm going to go over and make an open dot at 0, 0. But we know it's going to get filled in eventually. What's the slope of this expression? -1. Am I going to go down and to the right, or am I going to go up and to the left? Up to the left. Why am I going to go up and to the left? Because that's going in my negative x direction. Good. And then connect. Oh, that's not very good. Okay, so there's that piece of the function. Now let's do the other one. If I plug in 0 here, what do I get? 0. That's going to turn it into a closed dot. And from there, what am I going to do? Up 1 over 1. So what shape does our absolute value graph make? A V. If I were to think about it as a table of values, you can just watch this. So if I made a table of values and did -2, -1, 0, 1, 2, because those are our favorite numbers to deal with, if I were to plug this back into the original function, well, plugging in -2 for the absolute value of x would be +2. Plugging in -1 would get us 1. Plugging in 0 would get us 0. Plugging in 1 would get us 1. Plugging in 2 would get us 2. Are those points on this graph? -2, +2. -1, 1, 0, 0, 1, 1, 2, 2. Okay, so it's just kind of wrapping your brain around absolute value in a different way. Would it be wrong to make a table of values and get the graph? No, that's not a wrong process. It's just that sometimes you need to make sure you have enough of the domain values to get the actual shape of the graph itself. Okay, so what would happen to our graph if I added a +1? At the end of it. So now what would the pieces be? So if we think about it as a piecewise function, for all negative values, what would be the expression? Perfect. -x + 1. What would be the positive part? Just x + 1. Well, we can easily graph those lines. Those aren't hard to graph. They both have y-intercepts of 1. One has a negative slope. One has a positive slope. Okay. So when I plug in 0 here, what do we get? 0, 1. Plot that. I'm just going to make it close because it's going to close anyways. From there, my slope of this expression tells me to do what? Bless you. Well, we can either go down and to the right for negative slope, or we can go up and to the left for negative slope. Yeah, so we're going to go up and to the left. Okay, well, let's do the second piece. When I plug in 0 again, I get 0, 0, or 0, 1. I already got it there. My slope for that piece tells me to do what? Up 1 over 1. So what happened from the first graph to this graph? It just went up how many units? +1. If this said +2, do you want to take how many units it would go up? 2. If it said -3, where do you think it would go? It would start down at -3. The slopes would stay the same. It would stay 1 and -1, but now it would just go down into -3. Okay? What happens if we put a 3 in front of that? Nope, not yet. +1's still staying there. Maybe. What would be the pieces? So it would be negative 3x plus 1 for the negative. You are correct there. And it would be 3x plus 1 for the positive, including 0. Where's going to be the vertex or the bottom of the absolute value graph? Yeah, it's going to be at 0, 1 still, right? So 0, 1, 0, 1. So when we plot that, now what happens? Now what is my slope on the left side? So I'm going to go up 3 to the left 1. And then on the right, I'm going to go positive 3 slope, up 3 to the right 1.
The V just gets narrower.
Yeah, the V gets narrow. You are correct. Okay. All right. We can handle that. No biggie. What happens if I add a number to the x inside of the absolute value? Yeah, let's see what that looks like as a piece. Is everybody okay? All right. So if I had the absolute value of x plus 1,
Just be negative x plus 1 equation.
ooh, that's a good question. What would it be?
Because
So what would be the pieces? What would be the negative version of the piece for the negative?
would you put it x minus?
It would be negative of x plus 1 for the whole thing, right? So it would be negative x minus 1, technically, right? So negative x minus 1 for your x when it's negative. When your domain is positive, it would just be x plus 1. So now let's see what that looks like. When I plug in 0 up here, what do you get? Yeah, when we plug in 0 up here, we get negative 1. That's going to be an open dot. What happens when we plug in 0 down here?
1.
Oh man, they're not the same. What just happened? Well, let's plot them and see what it looks like. So at 0, negative 1, open dot. From there, what am I going to do? Yeah, I'm going to go up and to the left to get my negative slope on the left.
It's not the x negative one, it's the lower one.
Say it again.
It's not the x-axis you're doing negative one, it's the y-axis.
Oh, thank you. I didn't plot my point right, is what you're saying. There it is. Thanks. Okay. So now, what do we get on the other side? 0, 1 is up here. And my slope's telling me to do what? All right, so we got something looking really funky. Bless you.
Thanks.
Let's think about this for a second. When I do absolute value, can I ever have negative output? So whatever I put in to the function, will it ever pop out negative?
Yeah.
No. So this one right here, right now think about your y. Remember your y is your output. Y is output. Where do I have y output that is negative? Above or below my hand? Below my hand. So that can't be the case. So what do I need to do to it? I need to flip it up there. Get rid of it. we can't have negative. So there's our v.
So, wait, how can it go like that if it's everything above 1?
Right, if it stops at,
So if this stops at 1,
How can that connect down to the -1? Or is it the -1 going up to it? I don't know.
oh, I know what I did wrong. We made our domains wrong. If we think about this, these shouldn't have been zeros. Sorry to confuse you guys. If I plug in 0 here, what do I get?
1.
1. That doesn't get me 0. What number does get me 0 in here? So after -1. So if I plug in -2, do I get a negative value? Yes. If I plug in -3, do I get a negative value? Yes. If I plug in anything larger than -1, then I get positive values, right? So these zeros should have been -1s. That's where my error occurred. So if we make those -1s, that would change my points. That's where my problem was. So this would be -1, what? 0, right? And then this would be -1, 0, which would get us the same. That makes sense. Would it have been easier just to make a table of values? Sure, if I would have done -2, -1, 0, 1, and 2. When I plug in -2, what's -2 plus 1? -1, what's the absolute value of -1? 1. If I plug in -1, -1 plus 1 is 0, absolute value of that is 0. 0 plus 1 is 1, absolute value of that is 1. 1 plus 1 is 2, absolute value of that is 2. 2 plus 1 is 3, absolute value of that is 3. Are those points on our graph? Sure. -2, 1, -1, 0, 0, 1, 1, 2, 2, 3. They got me there. Okay? So, it's up to you on how you want to graph it. If you want to pick out the pieces and think of it as a piecewise function, that would be elevating your game. If you want to kick it old school and just go for a table of values, feel free to make a table of values. But you should be able to envision in your head what's happening with an absolute value graph. It should be a V, and it's either going to have a slope of 1 unless there's going to be a number out in front. That is it.